Hey, do you remember that time that plants almost ended life on the planet? Yeah, that happened. All right, let's get into it. So these are two events. It's the Kellwasser event and the Hangenberg event, I think named for places in Germany, where these sort of fossil layers were discovered. And these are both marked by sort of a black shale, which is like an all of a sudden everything gets really anoxic in addition to being kind of deep. So we've got a spike in temperature, ice caps are melting, the ocean level is rising, so water that was shallow is now deep, and all of a sudden these become anoxic because something has happened to plants in the ocean. Yeah. So, what was that? Let's find out. All right. The idea is that the culprits were these things. So, in the early Devonian, this is what forests look like. They're these little plants, and they're mostly like 30 centimeters or smaller, so like not very big. Yeah, yeah, little pint-sized plants. You could put them in a pot on your windowsill. They would look fine. They would not overgrow that space. And we have a fossil of one of these. Ask to see it if I don't get it out. Yeah, from a Devonian forest. I think ours is from one in New York State. And these things are kind of like moss. They're relatives of moss. They are living just on the surface of the rock. They don't really have roots that burrow down. And the big transition is to late Devonian forests. Because in late Devonian forests, this is plant on plant competition. There's still things like moss, but now they're down here. And just as we have ecological tiering in the oceans, where if you go up, you get to sample a different level, it's a little more brutal on land. Because if you go up and you spread out your canopy and you catch all the sunlight, there's no sunlight for whoever's down there. It's be tall or go extinct kind of world. And you start to get these great big tree ferns. Start to get these things that are going to eventually become stuff like trees. Big club mosses, giant, what are they called? Horsetails, essentially. Yeah, great big ones called calamites that just make forests, kind of like bamboo is now. But these are plants that are really little now, the survivors. As plants go up, in order to anchor themselves, they have to put out roots. Roots of plants are spreading across this rock, this soil that's never really been disturbed before. Because at this point in the Devonian, there are not many things that are on the land. We think it's mostly just plants, and things like arthropods, insects, whatever, are going to come later. Things like tetrapods are going to just start creeping out of the water to see what's going on there with this big potential food source that's developing on land. It becomes like an arms race to see who can actually drag themselves out of the water to get to the land where the big salad bar is growing, right there, waiting for you. And so as these roots are going down, the idea is they are breaking up the rock. And so now when it rains, they're breaking up the rock and releasing nutrients, which make plants grow better, which is fine. But as it rains, it's now flooding all these nutrients that were trapped in rocks out into the water. You're getting nitrates, you're getting phosphates released from all these rocks where they were trapped. And these are things that are precious to plants, precious to algae. And so now all the algae that's close to the shore has this feeding frenzy. Have you ever seen a really old pond? The way it has just a thick layer of disgusting algae, it smells terrible, growing over the top, completely blocking out sunlight? We think that's what happened. Temperatures go up. All these plants are there. They're completely blocking out the sun, and everything underneath them is just like the rotting debris from no sunlight. There's nothing left to eat. There's just destruction underneath these. Some of these may have been toxic, or when they rotted, they may have turned it toxic. If you've seen an old pond, once again, it's not a place that's healthy for creatures like us anyway. You'll get lots of real neat little pond life, little tiny arthropods, but a lot of animals cannot survive in those conditions. And so it's this transition from early Devonian to late Devonian forests that we think drives these big events. These are local transitions. Actually, they're transitions that are happening on dry land throughout the world as the globe heats up. What are the consequences? Well, the consequences are felt very strongly in the ocean because land is mostly just plants at this point. A few insects are just starting to try to figure things out. We see major extinctions. So these guys go completely extinct. Acanthodians, those are little spiny sharks. The placoderms, these are the ones with the big armored head like Dunkleosteus. Heterostraci, these awesome little jawless fish with a little armored head, gone, wiped out. The peak for chondrichthyans, things that are like sharks, is back in this time, and some of these do well. Coming out of this, they're going to end up replacing some of these older fish, and then they're going to sort of peak in the Carboniferous and then go downhill really rapidly at the end of the Carboniferous in the Permian extinction. This is when fish like modern fish actually start going. The ray fin fish, this is where in Sarcopterygian fish, things with bones inside those fins, like little arm bones in there, they really start to do well. And this is when tetrapods really start to do well, because these are an adaptation of Sarcopterygian fish to just barely start to come out and start exploiting that land with all that delicious salad growing on there, because these guys can't get enough of it. Yeah, and of the creatures that subsist on it. And so what we see there is things like placoderms just take a dive coming out of the Devonian. They're actually going to go down and eventually go extinct. We're going to have Sarcopterygian fish that were doing okay, but then they are not going to be doing well. But tetrapods are going to barely survive and then eventually do a little bit better coming through it. The major extinction events are going to be in the Frasnian and Fermenian. These are sub-periods of the Devonian, and these are going to occur at the end of the Devonian, start of the Mississippian. Who's going to do well? Things like sharks are going to do well. So chondrichthyans are going to do well, and actinopterygians, which are like modern ray-finned fish, are also going to do well because of clearing out and murdering all of these acanthodians. They do very badly and continue to do badly before they eventually sort of fade away and burn out. And placoderms take the biggest hit. They were dominant in the oceans, and they just get rocked by this extinction event, which may tell us that placoderms were doing best in the near-shore environment and did not do so well out from shore. It may be that these other things survived because they're able to move away from this devastation that's near land and survive for that reason. So this is looking at vertebrate animals, and so here's tetrapods in yellow, and you see this is individual tetrapods doing well in very particular spots, but also in general afterward. Actinopterygian fish, this is the light blue bar. You see they are the dominant kind of fish coming out of the Devonian, because placoderms, which are the light green band, are just getting wiped out. These are other types of placoderms. And various types of eels, various types of lampreys. You're also seeing big transitions there. And so it's not that everything gets wiped out, it's that all of a particular group get wiped out, which makes room. Because there were actinopterygian fish all the way back here, beginning of the, actually the middle of the Devonian. It's just that they don't become able to dominate the environment until the placoderms are killed off and until the acanthodians are pushed down and, kind of driven off. So, yeah, that's the story of evolution. One thing replacing another. There's never an unexploited resource for long so far in our history. Something always comes in and takes it. And I don't know. Maybe it's the cockroaches. Maybe it's us. But something. Anyway, you can always see big changes in the fossil record. These are also going to be shown by big changes in the foraminifera. Now, these are at the Cretaceous tertiary boundary, so I'm not even sure why this slide is here. But whenever we do get a major extinction event, you will always see that happening in the forams as well. And so, since these things are spread across the Earth, and in oceans everywhere where rocks are being actively built up, these are a great sort of record for extinctions. So this is why people study microfossils. They are the key to understanding time. Yeah, yeah. Learn fossils to understand time. That's maybe the message of this. I don't know. Thank you very much. This has been the end and mid Devonian extinctions, Kellwasser and Hangenberg events.